We're very happy to have with us today Archan Misra, who actually received this PhD from here several years ago. He had a very distinguished career with IBM and Korea. He's now an associate professor in the information systems in Singapore Management University, and he's the deputy director of the joint CMU and the Singapore University Center, which is named Living Analytics Research Center, and director of the LiveLabs Experimentation Platform. So he has worked on many areas, on communication networks and information networks, and he's currently interested in mobile systems, cloud P2P, middleware, indoor organization. He has had many distinctions. He has Best Paper Awards in EUC 2008, ACM, WorkCom, and IEEE Milcom 2001. He is the editor of the IEEE Transactions on Mobile Computing, and also the IEEE Journal of Pervasive and Mobile Computing, and chaired the IEEE Computer Society's Technical Committee on Computer Communications from 2005 to 2007. So welcome, Archan. Today he's going to talk to us about one of the labs that he's directing, the LiveLabs Testbed and mobile sensing-based applications. Let me just say, there's going to be a roundtable, 3 to 4 in the same room today, and one of the goals of his visit is try to establish some collaboration with this testbed that he has, which involves 30,000 users, and we can all try to see how we can use some of this data or do some interesting things with that data, because there don't exist testbeds like that accessible to us in the US easily. Okay. So welcome.
Thank you. All right, so good morning. I think I've already sort of know at least 80% of the room, or if not more. So I have an hour, and before I start the talk, just to give you a little bit of a disclaimer. So I moved to Singapore again a year and 4 or 5 months ago. So this talk is not going to be about sort of wireless networks. There's very little theoretical, analytical component to it. As you'll see that my focus is on building real systems right now and actually understanding the performance characteristics of that. However, I believe that the system will give you sort of a lot of unique opportunities to do very interesting theoretical work and actually test it out. So that's one thing I wanted to say. The second thing I wanted to say is this is probably not like the vast majority of academic research talks that come and talk to you about a protocol or one algorithm and it's proving its optimality or proving its complexity and so on. Because to some degree, I'm here more on an evangelical mission, which is I want to introduce the testbed. I want to explain, the opportunities that occurs, so the one line that I have for it right now, think of it as building sort of a mobile experimentation version of Planet Lab. For those of you who know what Planet Lab is, that's sort of the experimental version for internet sort of protocols and testing it out. This one is for mobile protocols. So it's going to be an open platform, which means that part of our metrics for which we get judged by success is frankly from the perspective of the test bed, just the way we're funded. Now internally as professors, we care for publications, we care for research. The test bed, the metric, there's only one metric, how many external parties are using that test bed. So to that extent that any of you choose to use it, it's a win-win for us as well. Okay? And the last thing I want to tell you about is the name of the university, because I think that sort of already creates some confusion. Because a lot of my friends said, I didn't realize you moved to a business school after like 12 years. So what happened was it started, this is the third university in Singapore, it started 10 years ago. It was in collaboration with Carnegie Mellon. Carnegie Mellon and Pennsylvania, the Wharton School. So it started with a business school, and the business school is very well reputed and so on in that part of the world. But what also happened is about 6-7 years ago, we created the School of Information Systems. So I am in the School of Information Systems, which is about 24 research faculty, who all, or 22 of them, hold degrees from computer science and electrical engineering. So it's very much a computer science, electrical engineering research, but directed at problems for businesses, etc. So it has an applied research flavor to it. There are 2 people who come from the business school, from management information systems, to provide sort of the business school perspective on number crunching, statistical analysis, and so on. So that's like a little background. Don't go through. I don't particularly like the name any longer. It's a university that started with a business school, but I'm not part of a business school, although we work very closely with them. Okay, so here's sort of the talk outline. So to a large extent, as I said, although there's 3 bullets, I mean, perhaps they'll be equitably distributed. But I really want to talk to you about LiveLabs. It's a project that has only started 2 months. And if I should tell you the timelines, we're promising 30,000 users, but the 30,000 users are not going to arrive until 2015 or so. We're going to have a few hundred users this year, a few thousand, 5 to 6 to 7, 8,000 users next year. So it has to ramp up. So that's, just to lay things in perspective. So I'll explain what LiveLabs is, what the goal, how we structured it, what the funding opportunities are, etc. I'll then explain, it's like a potpourri of research. I picked on like 4 research pieces of work that I have ongoing right now. They're all somehow tied to LiveLabs, or they can be tied, and the real intent there is not to tell you that, these are the 4 best pieces of research that I'm doing. But what I'm hoping that I'll do is give you ideas of what types of research are relevant to the LiveLabs testbed, or what the family of research in LiveLabs sort of might consist about. Okay, so let me get into LiveLabs. So as Dr. Barris was saying, I'm one of the directors of the LiveLab. We have a co-director called Rajesh Bala, who also works in mobile systems. He's an assistant professor in our department. So at a high level, the 3 bullet points you want to take away from LiveLab. So it's a combination of 2 things. It's a combination of a network wireless infrastructure testbed. It's a wireless infrastructure testbed that will consist of femtocells, LTE, some indoor directional antenna in urban spaces, etc. And we are working with quite a few infrastructure companies, and in particular the ones are Microsoft Research, Qualcomm, and another of our major partners is StarHub, which is the #2 telco in Singapore. Because you'll see that we need a lot of telco participation. They're donating about $8 to $9 million worth of equipment to make this possible for testing purposes. So that is the infrastructure piece, and I'll describe some femtocell work, etc. later on, that you'll see. The goal there is to do, I use this term usage adaptive, but the idea is that in dense urban indoor spaces. So in Singapore, one of the things I wanted to say was our focus really is a lot of life happens indoors, inside shopping malls, inside sports complexes, inside indoor entertainment arenas and so on, and these are very, very densely populated. You have, so for example, one of the shopping malls for which we have data right now has 70,000 visitors on a regular day. And if you come to the Christmas shopping season and so on, it has 200,000 visitors in a day. So, very, very dense. So there the idea is, for the next generation of telco, for what we call interactive digital media applications, video chat, real multimedia game playing, online game playing, etc. How can we make sure that the network indoors provides you that high bandwidth capacity even as loads fluctuate? So you have high concentration of users at some point, and you have low concentration of users at another point. So you can't obviously plan and provision to the maximum peak capacity, right? This is a basic thing that all EC engineers know. So how do we sort of dynamically move capacity around, if at all possible? Do data offload, for example, between a cellular network to a Wi-Fi network, for example. How do we do that in real systems and real scale? So that's one component of LiveLabs. The other component is this experimentation service. So once you have the infrastructure, and we have, so I should point out a few things just from this slide. So we're going to have 30,000 consumers. And part of the reason I claim, what is unique about us, and we believe globally unique. So is the reality that this sort of testbed is very hard to pull off in the US and Europe because of privacy and other sensitivity concerns. And it's not just a question of privacy laws, because Singapore has privacy laws too, but it's also really a reflection, in my view, of the outlook that the common citizens have towards privacy. So when you talk, for example, to our students in Singapore and the common members of the public, so the 30,000 users is going to consist of about 7,000 SMU students over 5 years, and about 23,000 members of just the general public, visiting shopping malls, etc. and so on. So they're all going to be all opt-in. There's no sort of secret monitoring. They'll all sign consent forms. We have to go through the IRB approvals, etc. for the university. But the whole point is they will get incentives, and the incentives will be in the form of cash, the incentive in the form of apps. In our school, for example, only people in the LiveLabs testbed will be the ones to first get the LTE network that's coming out in the next 3 months. So with these incentives, what we find is people are willing to give up and say, okay, you can monitor certain things about me with the phone. So it's just an outlook that people have, and part of it, I've had lots of conversations, and it seems to me that it's a reflection of an Asian mindset where, in Asia we tend to live in very dense urban societies. And this whole notion of privacy, I'm not discrediting it, it's important, but to some degree, it doesn't show up in the mindset of the average consumer. And the part of the reason I say that is, I go to movies, right? And, we were discussing, if you follow the press, there are all these laws that Netflix can't share automatically recommendations about what movies you're viewing, right? There's a law that says, which it's a privacy law because one US senator's, video renting habits got publicly published, and then this law came in, just historically. But if you go, basically there's no movie in Singapore that I can go and watch, I claim, in an anonymous fashion. Because any movie I go to, one of my students or one of my colleagues will be there. Because why? It's such a small place, it's so dense. There's maybe like 60 movie halls, and I know like maybe 6,000 people, so somebody or the other is always there with me, knowing what movie I'm watching. So this is just a reflection that, that some of the notions of privacy we take as critical here kind of tend to disappear over there, because people just say, okay, you know what, you're going to monitor me all the time anyway, or some of my friends know what I'm doing anyway all the time. So that's what I want to say. Now, come to the automated service. This is a very, very important part, and this is perhaps what's going to make this successful. So the analogy I have is take your favorite school, whatever. Take Maryland, take Princeton, name a school. And say you have a psychologist there who wants to create a study, and his study is that I want to push, an ad for bagels over lunch. And I want to display this ad for bagel for lunch to people who are sitting by themselves alone in a chair versus people who are sitting in a group. And I want to send it to people who are actually writing versus people who are sitting, just passively listening. And I have a hypothesis, some crazy hypothesis that, if I send it to people who are sitting by themselves and are not writing, they might actually act on the bagel ad and goes buy a bagel. So this guy knows nothing about mobile networks, knows nothing about wireless. Our claim is we'll give him like a web page where he says, okay, this is my control group, this is my subject test group. These are the context attributes they need to satisfy. They have to be sitting by themselves, they're not typing, etc. This is the kind of ad I want you to show them, 10% off, etc. Click, 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 go deploy, give me back the results of running this real ad. So the key point there is, if you look at where psychologists and behavioral people do these studies, right now they'll bring people into a lab environment and run these studies. Okay, say I'll give you this stimulus versus that stimulus and see what the behavior is. So what we claim is we'll do this in a real environment on the real people. So all of a sudden you will get the bagel ad. And we'll see what happens. We'll continue to monitor you. Did you actually go to the bagel store? Did you actually make a purchase on your phone, etc.? After we have enough statistically significant results, that's why we need 30,000 users, because it has to be some large number of people. We will give you back the result. So that is the most attractive power of this. And I'll tell you about a lot of the companies that we have already partnered, why they're interested in this and so on. Okay? So it's a combination of service. Now, the next thing I wanted to say, I talked about 3 spaces. And the 3 spaces have 3 different focus. So in our SMU campus is where we are blanketing it with femtos, with the DAS system, the directional antenna system indoors for high bandwidth, etc. Here the goal is to study or let people study what we call rich interactive digital media applications. So this is where, okay, what happens if you do high definition mobile gaming? What happens if I give you a service, for example, which lets you do video chat but only with people who are in the same building as you? Because that traffic, maybe over a femto network, doesn't transit to a macro cell. So I give it to you free, as opposed to charging you for it. So when you say what happens, we'll obviously study the network performance, but what our hope also is the attraction to the participant, to the companies, before they deploy the service, before startup deploys, they can test it out on these people and say, do people even want this service? So how many people actually will do video chat with people who are in the same floor of the building versus doing a video chat with people who are halfway around the world? Nobody knows the answer until you deploy it. You can't. So one of the problems telcos have always faced for a long time is, they can't predict demand. If you look at the 3G network, this is a classic example. They built it to a certain capacity, it got swamped, the traffic really killed the network, and then they said, oh my God, we don't have enough capacity. We overbid for spectrum, not enough bandwidth. So, but they didn't know which app would succeed and which app wouldn't. But this is hopefully a little sandbox where you can test these out and see what the behavioral patterns and requirements are. So that's our testbed, and this is where some of the key research participants are. The next one is Sentosa. Think of Sentosa as like a Disneyland of Singapore. It's got lots of attractions. It's like a theme park, ride, etc. And there, the idea, what is the end goal there? It's for tourism and leisure, we want to understand how we can improve, what sort of applications can improve visitors' experience. So these could be things like, I know the real-time wait times at different attractions, I know the movement pattern of people in the building, and I want to give you a targeted ad saying, okay, now, go to ride X instead of ride Y because the wait time's lower. Or maybe on your way, pick up give you a little incentive. You can get 10% off on a burger because I know you haven't eaten for the last 4 hours. You have your friends and kids with you, so maybe this is the right time to tempt you in. So there is this notion of very intrusive sensing and sense making that takes place, but hopefully here the whole goal is to sort of optimize the visitor experience. So one thing I wanted to explain, again, just in random order, if you look at what the LiveLabs core research team, which is the researchers like me, we are not interested in building each and every app. So our goal is that there will be maybe hundreds of thousands of apps random people will build. We'll give them the test bed. You come test your app. And you see whether or not that makes sense to you. Because frankly, it's not possible for us to scale up and build. We don't claim we know each and every right app. So the last one, which is probably the most interesting for a lot of people, is this. There are two places. One is called Plaza Singapore, one is called Clarke Quay. I'm not getting into the details. If you ever come visit, I can explain. But it's about these large malls where you're focusing on retail and consumption lifestyle. So the example, I can just give you a simple example. Suppose today you wanted to build an app, which is what I call sort of dynamic local Groupon. Groupon's very popular. So you say, okay, in the mall, I suddenly detect there are 50 teenagers who have been loitering for 2 hours, who have visited 2 or 3 stores and had coffee, but maybe not made a purchase as yet. And I realized that, from the profile of these 50, they're interested in Gap t-shirts. So suppose I'm a merchant that says, okay, right now, if 25 of you come together and collectively and buy this Gap t-shirt, I'll give you 50% off. How do I detect that this context is right? How do I deliver this Groupon? And what is the uptake? Do people take it or not? So this one has the most interest, as you can see, from a commercial angle by a lot of retail and consumption companies over here.
One question.
Yes.
In terms of usability, what kind of information will be provided by the lab testbed?
Yeah, so great question. So I'll come to that. So what we'll provide to you, there's, the honest answer is frankly we don't exactly know. But there are certain things right now we are going to provide is the location, we are going to anonymize the ID, we're going to provide gender, demographics, purchase profile, etc. One very important thing, we are targeting 1 meter location accuracy, location tracking continuously. So we'll tell you physically in the environment where you are at 1 meter accuracy.
And this profile is something that you constantly update, or is it something that...
Yes, it's constantly updates based on, because we are, so part of what I should explain is, this is very intrusive in some way. We are actually putting software on your mobile phone. It's a total sensor package that goes on your mobile phone. And now if you want further details, there's actually 2 types of sensor packages. For our students, whom we control, what we are going to do is, because that's where the tie-up with the telco is very important, they're basically subsidizing the handsets, and we will jailbreak or root the phones, and we will put software that can monitor down to the finest granularity. For members of the common public, obviously we can't do that. So there, all the monitoring is in the user space. So we get less granular, more granular monitoring in some sense. Okay? So just continuing with this theme. So what are the technology providers are over here? Just to give you a very high-level overview of why these companies are here. So what is Qualcomm's interest? Qualcomm is very interested in figuring out the next generation of sort of femtos, LTE chipsets, how they can optimize it to handle this indoor urban loads. I'm giving you a one-line blurb right now. So why are they partnering with us? So what is Microsoft's interest? Microsoft's interest is they have the Phone 7 operating system, which right now not doing that great, but maybe their claim is with Nokia's involvement, it might pick up again in Asia. What they want to do is they want to make this the most operator-optimized operating system. So as you'll see the examples later, what they want us to do is they want us to give you the user context at very fine granularity from the phone OS and share it with the operator network so that the operator can optimize in its behavior. So for example, if I detect that you're playing a video game and you're playing the video game that does not require, will not have any real-time packets for the next 30 seconds, can I share this with the operator? And can in real time the operator use this information to do some better capacity optimization or sharing? Right? So that is their goal. They want to make their phone OS, and frankly, none of these goals are going to be satisfied by one research group or the other. I'm not that megalomaniac to think that success or failure rests on just one group. But that's basically where they come from. That they want to make sure that hopefully if this phone and its capabilities behave best with the operator, operators will try to push more subscribers to these phones, right? Which is good for Microsoft. Now on top, again, ignore some of these other research testbed. So some of the companies that have already signed up. So CentOS and Capital Malls. Capital Malls is the largest mall developer property owner in Asia. It has a market cap of $40 billion. They own malls in Singapore, China, India, everywhere. They're a giant. Part of the education process is I didn't realize until I went through this process how much money and how much power is vested in companies that have nothing to do with information technology. So if you own property in Asia, you're far more valuable than anything else that you do out there. Quite honestly, it's just a realization that came to me. But the company, so DBS is the big bank in Singapore. It's a major bank in Asia. So DBS is in partnership with Visa. What do they want to do on the testbed? Why did they agree to sign up? So what they want to do is they want to do real-time discounts and coupons, etc. on their credit card integrated with the phone. So let me give you an example. So if you go to Asia, I know a lot of you are from Asia. In the Western context, it's very hard to understand. Every time I go into a restaurant, there's 4 restaurants in the food court. One guy says, oh, on DBS Visa card, 10% off if you dine 3 or more. The next guy says, Amex signature card, 20% off if you then get 3 entrees. The next guy says, oh, UAB card, 10% off. And you get frankly confused with all these promotions going on and so on. And now if you look at it, what they do is they tie up with merchants. So the simple example I give is they tie up with Starbucks. Let's say a card for students. Tied up with Starbucks, 10% off every Starbucks coffee you buy. So they actually collect all this data, run very sophisticated analytics to say that, okay, this is our customer segment, these are the people using Starbucks. But what they don't have is, if you don't go to Starbucks, but you go to, there's a competing chain called TCC, which they don't have a promotion. They don't realize you went there, and maybe out of the week, 4 times you're drinking at TCC. So they don't realize that you should really be tying up with TCC instead of Starbucks for this profile. But because we are giving you the physical location, we are telling you that you not only went for coffee at TCC, you went with 3 friends. And they go, oh, maybe we're partnering with the wrong store. So this is the kind of insight that they want to realize to aid their business decision making.
So as you collect the location information, you're actually reconstructing underlying social network as well, or?
So we are not reconstructing and analyzing new social networks, but we know, for example, for our students, we are exploiting, we know in which class who's studying, so we have all these sort of personal background information of their connectivity. Now for random people, like members of the common public, we do know who is your spouse, if they have signed up, we do know who is your children versus mother. So we can say you walked into the mall with your spouse versus you walked in with your mom. So we get that insight in real time.
If you walk with somebody else?
If you walk with somebody else, we'll say it's an unknown person. But this goes back to my point. If you walk with somebody else in the mall, and frankly this is scary for professors, inevitably some student will show up and say, oh, hi professor, who are you with? Because it's very hard to get anonymity in Singapore, it's too small.
True story. Outdoor games present, but true story.
Yes. It's okay.
No, here. I'm talking about I always do myself as a guinea pig because I don't want to talk about anybody else for obvious reasons.
Yeah, okay, so then show nearby, it's a classic example. They basically will show you what where are pants on sale, where are, coffee machines on sale, etc. It's like a local shopping app. And they obviously need to know your context. They would love to know, are you there with your spouse versus, are you there with your buddies? So they'll show you men's gear ads or whatever it is, right? So this is, I'm just illustrating some random companies out there who are part of it. And then there's a whole bunch of other companies we have talked to. And frankly, that's why I said the scale is, they're all users of the testbed. They will all run applications and experiments on it.
When they create data, they own it or
the data they create through their apps, they own it.
Okay.
Yes. But we are owning the substrate of the movement and context data because that comes to our infrastructure. So with that in mind, okay, what are the key R&D challenges? And this is probably the most important slide for the research people in the room. So one challenge, and for each of these, or for some of these, I'll give you some examples of ongoing work. So one is this deep, continuous context collection. In other words, I want to know, where you are, who you're with, how fast you walk. So for example, one of the things that I'm very interested in knowing, as you walk past a storefront, did you actually slow down to just look at the mannequins on the display? Because that gives you some degree of the person's interest. Or were you rushing to the metro station, so you just happened to walk past? You didn't really care that day. That's very insightful. So it's very deep context collection. And the big bottleneck there is frankly energy. So security is the other one, but the number one in my perspective is the energy consumption of doing all this continuous sensing. It drains the batteries in your smartphones and tablets really, really fast. And we'll talk of ways to improve that. The next thing, which is form of context, is very fine-grained indoor location. So I would like to know, am I standing on this side of the table, am I standing on that side of the table? In large indoor spaces with hundreds and thousands of people there. So there are challenges both on sensing and sense-making on the phone, but there are also challenges in doing it on scale with 5,000, 10,000, 15,000 users. And I want to emphasize that both these challenges, because I won't have time to talk about this later. So let me tell you something. So you know all about these algorithms like Radar, Horus, which was actually built by Agrawala and his team over here in Maryland. All indoor location, Wi-Fi based location tracking algorithms. So we actually took those algorithms and we started testing them. And it turns out that if you go look very, very carefully, all these work, they're all great work, don't get me wrong. They were all tested in buildings like this, in sort of campus, office space buildings. If you go to a mall, we started to test in a mall in Singapore. So two things happened, very interesting, okay? The physical structure of the building matters. It's a 7-story building with a big hollow in the middle, and basically you have concentric rings of shops at the edges. So what happens, one, with the Wi-Fi, you can't put Wi-Fi hanging in space. So the Wi-Fi is all at the edges instead of being uniformly distributed in space as you have in this building. Okay, this is a physical property. The second property, because of the hollow dome, so what happens, one of the basic assumptions in a building like this, if you have an access point on the 5th floor, the signal to the 1st floor is very attenuated because you pass through walls. In a mall, for example, we found out that the strongest signal doesn't come from your neighbor. It comes from the access point on the opposite wing on the floor above, because you have a direct line of sight to that guy, because it's hollow, right? So what I'm illustrating to this process is, the opportunity for algorithmic research, but also to realize that just off-the-shelf algorithms don't work in some real environments because of certain unique properties and problems. Okay, so we have to tackle that problem. Now, next comes the transient traffic loads, as I mentioned.
But this can be handled if you give one a architectural model of the building, and some idea of statistical
of the propagation.
And the location, then you can find the location of the cells so that you get very good coverage.
Yes. So yes and no. So that's one of the things we're doing. It's reinventing the models for understanding based on the construction and the layout of the buildings. Now, there are a few other things that happen in malls. So there are some malls that have electronic stores with all these computers radiating Wi-Fi like crazy. They they completely throw out the radio RF-based location model that we tried to do. These are all based on practical measurements we've been trying to take. So what we're doing, because I won't talk about this, we're, like many other groups, we're combining this with the accelerometer. Latest is the barometer, because phones are coming with barometers, which we use to figure out which floor you're on. And why these things are important? Because, so with an accelerometer, just to give you some preview on papers that are sort of under writing right now, I can figure out, did you take an elevator versus escalator? And why that's very important? Because I have the floor map of the building, and basically, even though I'm uncertain about your location, when I know you got off an escalator, there's only 2 points in the floor that have an escalator. So at that point, I know exactly where you are, down to either you're here versus you're over there. And I can use those to successively refine the estimates. So that's the flavor of the work. So the transient workloads, I'll explain that. This is all the femtocell migration, dynamic hotspot handling. As I said, when we have our underground student fairs or student activities, we have literally in a room like this, over 100, 120 students will just be standing next to one another. They'll all still be texting and messaging, God knows to whom, okay? But they're doing it, and we need to support those kind of bandwidths. These two They're listed here. So again, I wanted to be very honest. These three, I feel that, with my research and Rajesh's research and our core research, we have some handle. Of course, we always have need, I'm not claiming that we are the only people in the world doing it, so other people can improve on it. So the next one is run this automated social experiment. So we have to have a mechanism that goes, after that person clicks, you have to select the subjects, you have to validate the application that is indeed, you have to do static analysis, runtime analysis on the software to make sure it's not leaking context, it's using the sensors in the right way, etc. So all of that goes over here. How do we build this in real time and monitor, because we're deploying it to 30,000 people, and we don't want them to come back and complain that something weird is going on, with this phone. So how do we make sure that the process works and that the results we give back, people have faith in the integrity of our results? That's a big problem. This is where we are working with, for example, we have a very strong psychology group. So they're telling us, the types of ads and constraints and the interventions constraint. So very simple things, if you say, I want you to show you a beer ad. So the reality is that for any company who wants to accept the results from the beer ad, they will not accept it if you've already been shown an ad for a wine, because it contaminates your thinking process, right? So we have to discover and maintain those, what should I say, social or cognitive constraints on the network.
So that's what I was going to ask you. Many of the problems you're describing, there's a very strong implications, input, etc. that is needed from behavioral and psychological science.
Absolutely.
It's typically not at the model level. So what type of input do you have there?
So again, we will find out. As I said, so this project was funded only because we have buy-in from like 2 of the top behavioral scientists
You do have behavioral science
on the team, and they're core members of the team. One of them is called Professor David Chan, who's probably one of the top 3 scientists in Singapore in some level. He's a fellow of all psychologists. And he had a big role to play in saying, I want to approve this because for the behavioral people, this is something very useful. They can start building real world models because if they can do the sensing.
The other question is that, at least in this country, many of the applications we're talking about, they run across public policy and real addition.
Yes.
How is this happening here?
Okay, so
Is it done as a constraint? Is it done an experimenter who are told what I can do or cannot do? Or
yeah, so basically what happens is, we have an experiment admission board, which consists of not just directors and behavioral, but members of the Media Development Authority of Singapore, the Infocom Development Authority. So they will say, for example, suppose we give this to 16-year-olds. We can't run, certain types of experiments on 16-year-olds. Obviously, right? So there is this policy making saying you have to go through this approval process.
So the approval involves this board?
Exactly. Okay. And that's the way. Okay. And the last problem I wanted to explain is, support the privacy preferences. And this is, again, I know some of you have expressed privacy and so on, and I was saying that, we have some of this joint conversation with Adrian. So one of Adrian's recent work, which I find very interesting. So we normally tend to think of privacy as, the user specifies, okay, you can't track my location when I'm in my home. Or you can track, my location when I'm with someone else in the mall. So you can specify, with my spouse you can, with my kids you can't, because I don't want you to know where I'm shopping with my kids. So those may be all constraints, challenges to implement, but to some level they are basically policies and you have to figure out a way to do it. But some interesting new things came up. So one thing we're doing very extensively is using the accelerometer. For those of you doing mobile sensing, very common. Use the accelerometer to figure out how fast you're walking, how many steps you took, are you on the elevator, etc. So what Adrian showed that basically, if you take the Android framework, you have the mobile sensor just, our context monitoring, just monitoring the accelerometer. And suppose that's running in the background. Suppose you have a banking application, right? You have a mobile bank, you should open it up, and every time it asks you to enter your PIN number or password. So it turns out that by doing machine learning, just by the minor perturbations in the accelerometer, he's able to reconstruct your password. Okay? Think that's a really, really powerful covert sensing channel. Because whenever you type 1, 2, again, it's not perfect. It's not that it will go for one individual. Statistically, you crack 20 out of 1,000 people doing that, you're in business, right? In certain businesses, yes. So that's why I say that we fully recognize, and frankly, this is where we are under-equipped. So far we've paid lip service. I want to be very upfront when I go to give academic talks. that we really need help and assistance in understanding the privacy security challenges to this monitoring system and what sort of policies we apply at the phone, what sort of policies we apply when we have the aggregated data that we release, or when we do sort of release of movement trajectories and statistical patterns on the data.
But I can, if I have a user-friendly way to forbid me from getting any information from my onboard sensors, now that works.
Yes, but these are all opt-in people who have said that they will.
I understand that.
Yes.
But if I'm one of those that I say, I won't have the option to go to my screen, put up all the services, go like this with my finger and say, forbid all those to export anything.
Right.
Then,
Nothing works.
no, but for the period I have that. The other problem that I want to ask you is that, at least in my limited experience with the iPhone and the interaction of the iPhone with service providers, there are many things that we do not know about, for instance, complicated charge strategies and others, and you get ripped off until
Okay.
you figure out. So, user friendliness and ability of the user to understand what are you giving them and the rights or not rights, it's going to be very important.
Absolutely.
Otherwise, the psychology of the user is going to say, oh no, no,
Nothing,
no.
everything, nothing, say no to everything.
So you have to provide in the device, right, user-friendly ways. And this came out from Facebook and Google. For an average user who's not a computer expert,
Right.
to restrict certain things easily.
Exactly.
Otherwise, the first time they get burned, they're going to throw everything away.
This is what happened with Bluetooth, for example, if you realize. We all said Bluetooth turned on and we were getting all these spam ads you were getting from things around, and people said, okay, turn on Bluetooth. How good is it? So basically, 95% of the people have Bluetooth off. I don't know how many of you have phones and you turn Bluetooth off. You don't think why. There may be services, but you don't actually use it. Yes, so and that's why I said for us, this is right now an Achilles heel. I mean, we don't have a good answer for it. And if you know what sort of work I do, I'm not the expert on it. So we need the collaborative group, etc. too.
What's the delay that a service provider sees between the collection of location information and the return?
So there are many, basically, what we're talking about right now is less than a minute lag between your real movement and so on. And I'll come to that later. I mean, we can actually, with certain ways, we can do real-time collection of location. Real-time meaning like less than 1 second, 2 seconds, even without burning the energy on the phone. Okay? So,
But the energy should be very huge, right?
issue is very huge.
I was listening to a talk from the chief of engineering of platform devices, right? And he was telling this quite incredible thing, right? Part of the problem that iPhone had, and several of the smartphones had, was that if you left consistently, continuously, with GPS on,
It's like 3 hours.
it burns 70% of the energy.
In 3 hours, you drain the battery. Yes,
And they don't tell
absolutely.
you that.
No, they don't, and those are the sort of work that I'm doing right now. Just to tell you exactly. So we have to solve the energy problem now. In the interest of time, so let me get straight away.
I'm saying this because several people here, we have an initiative on green communications and energy efficiency. So that's a very good program to emphasize, that having dynamic allocation of bandwidth and services from the perspective of energy is extremely important,
Yes,
even for the existing device.
and especially for mobile devices, because if you look at green computing, right now the big thrust on green computing, as I see as a as a member of the community, not as an active researcher, is basically server farms, right?
And data centers and stuff like that.
Data centers.
So there's
That's
a lot of opportunity
in mobile world as well. That's what I
Even
said.
in the hardware.
This is another of Qualcomm. So if you remember Sanjeev Nanda, I don't know if you know Sanjeev.
Yeah.
So he, as I said, I'll talk to him next week. So they are trying to figure out how much of this sensing and analytics algorithms do you push on the chipset.
But the problem that this fellow was explaining to me is that they're working with AMF, which is the company that gives them the license for the chips they use in the mobile, change the chips to allow to have specific hardware to be able to allow you to do these interruptions.
Yes,
Because it's not just enough to say, I want to do it. The
Exactly.
hardware has to be able to do it. So the hardware has to be modified to allow you to do this energy control.
exactly right. This is very, very important, and this is the conversation I've had with Qualcomm. And again, I want to emphasize, again, I take this view that I'm not the researcher doing the hardware.
It goes
research.
vertically from the application down to the hardware now. This energy
So, for
efficiency.
example, whether we model, for those of you who know, the Android system, so we made changes in the user space, which is where most of you will write Android programs, and then we also went below the JVM. We went to the shared library and we modified in the kernel. and there is an order of magnitude difference in energy efficiency if you can modify in the kernel.
Absolutely. So another question that some of the people here are pushing them to learn more Android. Is Android your main
Yes.
software for the?
That's because, I mean, okay, so a couple of reasons for that, just to be upfront. The fact we're working with Microsoft, they basically said that you will not work with Apple. Simply put, I mean, they're investing. They're giving us money. They're giving us researchers. I mean, it makes common sense. And secondly, as a researcher, I can just tell you up front, I mean, iOS is a terrible system to use. It's so closed. I mean,
yeah, that's exactly why we are doing that here, because we want to have open things.
Yeah.
Our ideas can be easily implemented and so on.
and Android is really ramping up in popularity. Even and again, Singapore still is an exception. People are still buying iPhones.
But they kept on the curveball, right? So I want to download applications to my smartphone. It's an Android phone, right? The usual model is anybody can send me applications, I can put them in.
You don't have to go, which you don't have to go to the marketplace.
Right?
Yes.
At least in Apple, they control them and then they keep the things. And this already has created problems.
Absolutely. So we recognize those problems. Okay.
That's the few.
So let me talk about, so I broke it up, now that I gave you, I said one research challenge was to acquire context, right? To know real-time context. So for that, I'll give you two ideas. The slides may be messy, just listen to what I'm saying and you'll get the concept. And part of the reason is that's why I said it's not like a real research talk with lots of graphs and theorems. I can come and tell you these things offline, and then I'll tell you about two projects where we're using the context. So one idea is we want to do accelerometer-based activity recognition. How much, continuously, okay? Running in the background. When did you walk, sit, run, take an elevator, etc. So the basic idea is if you want to run this in the background, the conventional model is you have sensing at a certain sampling rate. You pick 16 hertz or 50 hertz or 100 hertz. 100 hertz is too high. You only need that for gestural recognition. But basically what you'll find is like if you want to detect when you're climbing down the stairs versus climbing up the stairs, you need 100 hertz because you need that very fine grained sampling and the features from that. So that's one thing. The other thing you're doing on the phone, you're using two types of features. The features you use are frequency domain based, so you take an FFT and then you take the entropy of the signal, you take the dispersion coefficients of the signal, etc. Or you take a wavelength transform of the signal and so on. And time domain features. So you look for number of zero crossings, which is the number of times you change steps, etc. So if you don't understand, so our goal is we want to do this monitoring all the time without sacrificing accuracy. So with some experiments, and again I'm giving you very high level overview. If you look at these two slides, x-axis is the sampling frequency. This is results from an Android phone. Y-axis is the energy taken in joules. Actually, this was done for a 15-minute interval, if I remember. So one is if I only use time domain features versus if I use time plus frequency domain features. So the whole idea is that the more features you use, the better classification, right? You have more classifying power. So the two things that strike out is if you increase frequency, obviously, this is total energy. So it's sampling plus computing. This is all happening locally on the phone, no communication, okay? So obviously, if you sample more, the curve goes up. You're generating more samples, you're taking more energy, etc. But the other thing is if you use the frequency domain features, on top of there's an additional penalty to pay. And the penalty to pay increases non-linearly in frequency. Why? Because for an FFT, the more number of points you have, you need a bigger computation. And it actually shows up in an appreciable difference in the energy consumption of the phone. Okay, that's the basic story. And very dense charts, I apologize, but now I broke it up into individual activities. If you can't read, downstairs, escalator down, normal walk, sit, stand, etc. And this line is the accuracy, the classification accuracy. So the two things that turns out is there are only some activities, most activities you can get good classification accuracy at like even as low as 0.5 hertz.
What's that? What is the level of accuracy, like what percentage?
This is, so it goes from about 80% to 98%, so across different applications. Now, the other thing I wanted to show, so that is per activity, and also for different activities. In some activities, you don't need time domain features. In some activities, you don't need frequency domain features. So we did sort of an exhaustive study. And where am I going with this? I'll give you the tagline. So the tagline is, for each particular activity I am in, there is the best combination of sampling frequency and whether to use time plus frequency or frequency domain features. And what it does is, so obviously if you use higher frequency and you use more features, you will get higher accuracy. But the point is the sensitivity curve. So for sitting, for example, at 0.5 hertz with time domain features, you get almost 97% accuracy. If you go to 100 hertz and you include all the features, you burn up a lot more energy, but you only get like a payoff of 0.5% increase in accuracy. So it's just not worth it. So after all this experimentation, we basically build up a table saying, if you are in this state, what is your combination of sampling frequency and combination of features you use? Very simple idea, right? Now, once we have this, what is the algorithm? So I didn't actually show up mathematically. So mathematically, what I do is I start the phone. It's a simple Markovian, I mean, for the EC crowd, it doesn't even matter. It's a simple state transition model. So I start in an unknown state where I sample at 100 hertz and I use all features. As soon as I have confidence that, let's say you're sitting, I transition to the sit state and I lower my sampling frequency, I lower the set of features I use, and I continue to use that until my confidence in that state, the detection accuracy, drops, which means I have changed state. I go back to my unknown state. I try to detect the next state. So very, very simple model, right? I mean, you can obviously start thinking you can create more sophisticated hidden Markov models, n-order Markov models. To do all these things, we haven't done any of that so far.
Is there a lot of variation from one individual to next?
In terms of the features to use and the accuracy, no. The variation is the classifier has to be trained per individual. So your signature for walking is different than my signature. But what features you need to identify, that's more or less the same. So what I wanted, now these are real results out of, we monitored, this particular work was done with EPFL in collaboration. So these are real results out of monitoring people, a group of students for about 1.5 months. And what is the key insight? So if you look at the color-coded graphs, this is how people spend their day. Not surprisingly, people spend a lot of their day sitting, sometimes sitting in a relaxed state, which we define, I'll tell you. And they obviously spend very little time standing and walking down the stairs, etc. Now, now unless you're some kind of, you're training for some international stair competition, so maybe you do that. But, so again, I'm going back to the real data, and on the basis of that, I wanted to show you that this is the real battery consumption of people, either when there is no monitoring. Now, the important thing to realize is we didn't do a trace-based simulation, so we never did apples-to-apples comparison. We actually said we took one guy, this is 1 week of data, this is for the next week of data, this is for the next week. So there will be individual variations. Sometimes they use the phone more, they use the phone less, etc. But the whole point is that if you didn't do this adjustment, if you did what the most common practice is to sample at about 5 to 16 hertz, because you don't spend too much energy and you get reasonable accuracy, you will miss out on some of these features, versus if you use our approach, it's much lower overhead as opposed to running, it's continuously running in the background, and we detect all the events. Now, one thing that we cannot detect is, if you're sitting and you just stand up and walk and you sit down. Because remember, we're doing this straight transition, so we have some latency hysteresis in the system. But that is okay. So this is a model not to detect like fall in elderly and so on, which requires you to detect these very transient events. But this is perfect for us to detect long-term patterns. Are you walking in the mall? Are you sitting down, etc., which can be the basis for our intelligence. Okay? So let me come to the other part, and this I have to breeze through because frankly, the math for this will take some time to explain, but I'll give you the high-level idea. So the high-level idea is, okay, you can take ECG, HR, temperature, accelerometer sensors on my phone. So on my phone right now, so it's a combination of two ideas. So on my phone right now, suppose I want to detect something like this. I have a system that says, I want to detect if there is a lot of movement in the room, and the room is very noisy, and the number of people in the room have changed or something. That is a trigger for some kind of activity. Okay, maybe the meeting is over and so on. So right now the model of context recognition is I'm running, suppose we're all interested in this. I run this on my phone, you run this on your phone, you run this on your phone, and we all use our own sensors to detect this activity. So the high level model that I'm going to is a more collaborative model where we view all our sensors as a collective shared resource. So very simple idea is the following. Suppose I want to detect the sound intensity in the room. As long as I believe we all will observe the same sound level, the most simple thing to do is, for 5 seconds I use my microphone sensor. For the next 5 seconds we'll use your microphone sensor. For the next 5 seconds we'll use your microphone sensor. So we'll amortize the cost over the number of participants in the room. Right? So that will lower the sampling cost as well. So what this sets up is an interesting problem, and I will talk more in detail because I just wanted to touch. So it sets up an interesting problem. Suppose none of you are running the application, but you are willing to let your sensors be shared. Big assumption for now. So I want to detect this activity myself. Do I use my local sensor and run the feature extraction on it? Do I use your sensor and run the feature extraction on my phone? So you just send me the raw data. Do I use your sensor, run the feature extraction on your phone, and just send me the end result? And you want to do this dynamically because people are moving in and out, who is in the neighborhood and so on, right? So with that as the background, let me give you what we call the aqua. So there is this next piece, which is a query optimization piece, which is frankly to me the most interesting piece. So remember this thing that I said, if the sound is high, if people are moving around, and maybe if the temperature in the room has gone low. Let's take this. Now in normal model, this is what you do classically in compilers. In a normal, if you look at the vast majority of sensing, they'll say, all 3 of these sensors they sense, they send you the data, you run the query. Now clearly, if you look at this query, you say you can do smarter. It's a combination of 3 acts. You first evaluate one predicate. If that turns out to be false, you're done. You don't need to evaluate the other queries. You don't need to transfer the data. You don't need to do anything, right? So there is a model of sequential query optimization. I mean, you do this in all compilers will do this. They will not evaluate all the predicates at the same time. So with that in mind, little more detail. So now I have a choice. So my choice, so the classic choice in compilers, I'm just using the AND query. It says do the most selective query first. So do the one that has the highest probability of being false, because that will abort the query. Now to even acquire the data, you have to acquire in batches. And I know I'm hand waving. One thing we found out, let's use either Wi-Fi or Bluetooth. The reality is that the cost of acquiring the data is not constant. We sometimes in basic theoretical modeling, we assume a fluid model, right? So many bits per second, or bits, hertz per bits, joules per bit cost. But if you look at real radios and antennas, they turn out, so things which are well known for Wi-Fi and Bluetooth. In Bluetooth, to switch from a low energy to an active state, you have a certain threshold of time you need to wait. In Wi-Fi, you go from idle to active, you have a ramp up power that you need to expend as you turn on your radio and so on. So the amount of data, so the bottom line is, transmitting data continuously makes no sense because you're keeping the phone on. But so you have to transmit in bigger chunks. And the chunk size you choose, because this is continuous sampling, it will turn out to be different in different radio technologies, because there is all the transient cost of switching between state. So something that says that is obvious that, okay, instead of transmitting in 10 bits every 20 milliseconds, suppose I transmit 500 bits every second. It may turn out that that is even worse. Because, okay, sure you do the transmission efficiency, but you have to switch the radio on and switch it off again, and you pay that energy. So again, I have lots of detailed, measurement-based experimentation on phones.
But this will depend on the device.
This will depend on the device and technology, absolutely. But what am I coming to at the end? So I just created.
So what is the incentive for the nodes to collaborate on this sensing exercise? You have to give them something.
Yes. So there are 2 parts to this. I mean, you are almost taking this. So one part of this is, if we are all running the query, then we have an incentive to collaborate, and somebody has to discover and give that incentive. That look, you also need the microphone data, I need it, so why don't we time share and use it? The other model is, this is where the game theory, one of your work was mentioning. So I come to this mall. So in the mall, for example, we have this notion that we are going to give this discount if 20 people are walking around in the store. Now, this sets up this interesting game model. It's like the tragedy of the common stuff, that I don't want to give it out if 20 other people are giving it out. But if nobody gives it, we would never know the 20. So what we are creating is this incentive model, and there's a privacy trade-off cost here as well, right? The model that says that as more and more participants join, I give less rewards to people. And this is one of the problems I want to study, that in a dynamic setting, what is the right game formulation to...
We have studied constraint collision games, right?
Yes.
In this context, and where we're moving now is where basically constraint collision games, you get benefits from collaboration and costs of collaboration. This can be multiple benefits.
Absolutely.
But what we're moving now is where both depend on the state of the ensemble. So you can
That's what
actually do what you do.
And that is where I'm looking for some collaboration, because that's not my core area of expertise. I can give you the problem formulation, etc. But so just to stick with one of the things we wanted to do was, so if you look at that query, something random. So the most database-oriented people will not look at the cost of acquiring the data. They'll just look at the selectivity predicate and say, if S1 less than 10 has the highest probability of being false, evaluate it first. But what we also look at is the cost of acquiring the data. Maybe you get it from a sensor on another phone. You get it from running some kind of feature extraction and classification on somebody else's phone. So the bottom line is it's a multi-objective thing, and we do the classic pop out here. We normalize the cost. So we basically, the new thing is we look at the cost of acquiring. We like to select from the sensor that, given the current evaluation state, select from the sensor that's the cheapest, but that has the highest selectivity. And this is not a static optimization, because, and I won't have time to go over this in detail, it sets up very interesting query problems, because imagine multiple people are running the query, and each has been partially evaluated. So some parts of the query will turn out to be true and false. So depending on how much more of the query you need, some of these acquisitions will be X'd out. You don't need them anymore. So you dynamically, during the query evaluation, so this is in the order of micro or milliseconds, we are re-optimizing the schedule in which we acquired the data. And we showed you can do this on a phone.
For how many phones?
2 phones. Okay, this is what I said. Right now, and that's why I said it's not complete work at all. I mean, I just showed that the concept can be realized. Whether it's practically useful or not,
But if you had to sell.
This is exactly. So what I wanted to show the results, again, let's not talk about it. This is the naive approach where you collect all the sensor. This is the static approach where you set up the query plan once. And this is the dynamic approach where the query plan is changing within the query evaluation. And without going further into details, one of the interesting things is, this is more of an instruction to the PhD student. This is the total number of bytes transmitted. This is the total energy consumed. This is for Bluetooth. This is for Wi-Fi. The important thing is, look at this. The total energy, the bytes change. The energy doesn't change. This is because of those transient characteristics of those radios. So my whole point here is that it is very technology dependent, the benefits you realize from these approaches. So you cannot just do a theoretical evaluation and say, oh, I saved 70% in communication bandwidth, so that means a huge savings in energy. It may not turn out that there is that appreciable savings in energy.
So what you are saying is that something may emerge, but some companies may not like, that certain operating systems in combination with certain communication technology with certain chips are
better. Exactly. And this is the interest of, again, as I said, they're one strategic partner. This is why they're partnering.
By the way, it's not only Qualcomm. I know, but although they're not talking about it, but I can say this, that Intel has a huge effort in this direction, because the whole company is doing bet on whether they're going to be able to come out with specific chips for the mobile world, because the mobile world is the increasingly
and they got shut out of it.
Of the demand,
yeah. They got shut out of it by,
And they know they're behind, but they're looking at all these aspects.
Yeah, the Snapdragon basically killed their...
That's why the Qualcomm people were interested in us, is because Intel is a bit ahead on introducing into the chip level hardware-based security.
Yeah, okay.
Because they were the pioneers where Qualcomm is. So now Qualcomm is trying to catch up. So this is
I see.
It's very interesting product. But you're right on the mark as far as what they believe is the issue. But what I was surprised to find out is that it goes down to the design of the hardware.
Yes.
They're taking the IP from AMF, which is a leading company in mobile chips, and they're modifying the chips to allow this advanced controls that save energy.
Right.
At the device level, this to me was very surprising. I thought you could do everything with software, that's okay.
No, but I think this is again this cross-layer optimization which we've seen again and again in wireless networks that really makes a difference. So I'm going to conclude this part of the talk of this thread. This was all about context extraction, which I wanted to show was I have two phones running these two queries, and essentially what I want to do is somehow combine them and to say that the P2 sensor is shared. I either get the data from one and I transfer to the other, or I do time domain sharing between the two, right? These are query evaluation graphs. If you don't understand it, it's okay. But one point which was brought up is, I demonstrate this for two phones. So where do we believe we are going? Because, there's a classic model. How do I find out with who else to share, etc. So part of the approach we are taking right now is, it goes back to the femtocell. So I'm saying you can share the context. The femtocell is the local coordinator. So anybody who registers with that femto, they will share their query. The femtocell as a central guy has all the knowledge, will discover and optimize the best pattern and direct each phone. Okay, you share with this guy this many seconds, etc. That's the model that we're going after right now. We haven't implemented this, it's still far away.
But this should allow a mode where if I'm walking around with my smartphone, I should have a service activation button that says, find femtocells from this service and register to anyone that's relevant.
Yes.
At the same time, right? Or shut off.
Right. Now, to tell you, to give you the full story on this, when you said Tom Richardson visiting, so our conversations with Tom, and he was very interested in the research, was instead of going through the femto as a central, can't we do it device to device over flash link? And he was interested, but basically they aborted the research thread, so we haven't gone.
I made this discussion with him, but it gets to a whole other.
Right. Again, I'm just, one of the advantages of academia, I can tell you openly what the problems are.
No, it's not proprietary. It's just a very difficult problem to figure out the ad hoc mode or the cell mode, because it varies so much on the size and the parameters.
Right. So this is where we were going, but we're not going down that path. Right now, we're going through the femto path. That it's a star topology. Everybody reports to the femto, and the femto decides the optimization. Okay. So I think I have about 5 more minutes because I started around 11:15. So these two were all about acquiring the context. Now I'll give you 2 uses of what we're doing once we acquire the context, all preliminary work. Now there are many other uses, and as I said, each application that people write will use the context in different ways. So we are not in the business of compiling an exhaustive list of how you can use the context. Okay? So here's the femto problem. So what we have, if you look classically at what the femto network was deployed, so let me give you a little anecdote even in Singapore what happened. So Singapore and StarHub, in case you didn't know, was the world's first commercial deployment of femto. They provided the femto individual cells to people. They went and they flamed out spectacularly. The service was terrible, the first generation femto. And their CTO said, okay, we're never going for femto again until hopefully we have changed our mind. So the problem that happened with femto, it's kind of very interesting. So they were selling femtos as a personal gateway. You plug it into your home as a Wi-Fi access point. So when you're in your home, you have great signal. Now, of course, if you don't do the right interference management, you have great signal. If you're in the same spectral band as the macro, your neighbor has terrible interference because they're locked out. These are blacklisted, whitelisted femtos. Only your phone and your wife's phone can connect to it. Nobody else can. Now, this may not be a problem in vast parts of the US. Why? Because it's a 10-meter femtocell. Your next house is 20 meters away. In Singapore, where everybody lives in apartment complexes of 30 floors and 6 apartments, you basically killed all the other people 1 floor down, up, and around you. No, I'm just giving you, again, a very true story that I can share. What happened was the person who got the femto was actually very happy. But the StarHub started getting enormous complaints from everybody else around them that my cell phone doesn't work inside the building. What's happening with you guys? Your service sucks, etc. So they gave up. So one interesting insight to share with you, they are going back to femtos again, but their model right now, they are operating the femtos on a totally different band. So it's a totally different 2.1 spectral band, gigahertz spectral band. And they made a decision to reserve an entire band for spectrum because try as much as academics want to convince them, right now they're very unconvinced that you have right interference management. And Qualcomm will disagree with that. They say that they have solve the interference problem. And I know many, many academics have worked on it. But I'm just giving you an illustration of a service provider mindset. So with that in the mindset, so what we are going after, remember I said our campus, each room has a femto. So we're basically bringing the cellular network indoors. It's a cellular deployment, overlapping regions, etc., etc. Now, something very, very simple, which nobody needs an explanation for. So what happens during handoff? What is the process of handoff? At least in 3G, it's a cell base station initiated handoff. So you are connected to this guy, you keep moving. At some point, the signal strength from this guy becomes stronger than this. So there is a threshold that it has to be stronger by a certain amount. And there is a time hysteresis factor. So it has to stay stronger for a certain duration. Then you hand off. Right? This is 101 of handoffs. I mean, this occurs everywhere across the state. So what happens if you're moving too fast? If you move too fast because of the time constants, if they're fixed. So if you move too fast, you will be here when you hand off because the time won't have elapsed. So you will have very poor connection to your serving cell for a long time. Now if you move too slow, then again you'll be handing off really, maybe at the edge where you do not need to hand off, for example, right? And suppose you are coming back, people randomly walk indoors, this is very targeted indoors, you'll be ping-ponging and handing off even if you're moving too slow. Again, not unique to femtos, it's known. So even for macros, operators have been doing this. If you're in a car, they'll know how to hand you off more preferentially if you're a pedestrian, etc. So it turns out in indoor work, the ideas were brought. A lot of work in simulations, lots of groups have been doing, but very little capture some practical challenges. So again, I'll give you the measurements in a second. So the first thing is in indoors, the signal strength itself from these two guys is not constant, it varies a lot. We have basically observed in our indoor thing 20 dB variation in signal strength, just across time of the day and different days. So what that means is you can't, even if I were to set the thresholds on a per person basis, I wouldn't know what thresholds to set because I wouldn't know where to predict. So we have to take this dynamism into account in real life. Now a lot of papers have said if I know the movement speed, I can give you the right parameter and hand you off. Now movement speed, basically all those papers were done for vehicular handoffs, where you have GPS, you assume you know how fast you're moving and you can have it. Now remember these are phones, as I said at the accelerometer I can predict some movement speed, but it's very inaccurate. I don't have GPS, so I really have a lot of margin of error in how fast this person's moving. So I have to make it robust to that. And as far as we know, there isn't really strong prediction of movement patterns of users indoors. Outdoors, you have Manhattan networks, cars moving, it's very predictable in some way. But you might go out, go to the restroom, stop by the ISR office and so on. It's kind of hard to predict what happens in large groups. So anyway, so we have like 3 femtocells in 2 floors each of our building. So I'll give you the research question. The research question is, can we use the real-time analytics of the collected context to improve the wireless network ability? So I claim our novelty, and I'm open to sort of hearing criticism and hearing critiques. The novelty is this. So far, a lot of the handoff work and management of things has been done based on RF sensing. So you sense the RSSI, you sense, the variation in signal strength. Very little has exploited this other group and personal context, which is how fast am I moving? Am I moving with a group of people? Am I moving when the meeting has ended, which means with a strong certainty we'll all move out? Am I going out when the meeting is still on, which means that I might step out and come right back? I'm probably not heading to the cafeteria. So our goal is that we can use this other sort of device or higher layer context and combine it with the radio context to do better decision management. And that's what this diagram shows. So we have all the RF measurements, neighboring cell tower information, neighboring cell RSI, but we also have the phone sensor data. Am I walking, running, how fast? Am I going with a group of people, etc.? Do I go for lunch every day at this time, etc.? All that information. And I send it. So again, our target point for doing this adaptation right now is at the femtocell gateway. So we're in conversations to get 2 different femtocell gateways from 2 vendors. And we want to detect, set the parameters in the right way. So just to give you the empirical data collection, okay, I'm not going to explain the slides. So the 2 things I wanted to say, the user movement speed strongly have influenced the handoff behavior for existing femtocells. I'm not talking theoretically, we can show. So the 2 things that happen. So depending, as I said, on the speed of move, I found that the point where I handed off from one cell to the other was off by as much as 10 meters across different people. And that's basically the radius of one cell. So that shows that we do need very accurate monitoring, and this is a problem. Okay? The second thing that we found is, as I said, there's a 20 dB variation in power. So that meant that I can't do offline learning to predict where you're going to hand off. I can't do cell planning offline. So where are we going? So our basic philosophy, which some of you, if you're interested in collaborating. So one problem, and the Microsoft guys we are collaborating because they have done some work on it, we are going to crowdsource real-time measurements from all phones. So basically all these phones become sensors. They give us real-time measurements of the signals you're operating, and with that, in real time, I want to create the real-time RF map. So I want to figure out for different rooms in different sectors what the attenuation coefficients are for, let's say, on a 5-minute or 10-minute time scale. So if I can reverse engineer that, then I can predict where you're going to hand off, etc., and then start doing all the other adaptations I want to. Now, why does crowdsourcing actually make a lot of sense? My personal opinion. So crowdsourcing, what does it mean? That means when you have a lot of people, you have good quality sensing and data. But when you have very few people, it's night, or maybe it's 8 in the morning for research students, nobody's around, right? You have only one of you has come in that day for whatever reason, not much data. But my claim is at that point there is no congestion on the network as well. So you don't need more accuracy. So it's a natural fit to do the crowdsourcing and accurate construction when you have dense, high density people.
That also changes quite a bit whenever you move an object around.
Yes.
So how do you keep track of this all the time?
No, so we don't see, that's what I'm saying. So you can move, you close the door, you open the door. So I don't keep track of that. I'm just saying the phones here are constantly reporting what the RF patterns they see now.
Okay.
And on the basis of that, I reverse compute what the RF map is now.
Okay.
After this, if you close the door, the reports will change.
Okay.
And I will compute a new map for you, right?
So when you say you are the base station?
I'm the femto
Femto
gateway.
gateway.
The femto gateway actually, because it needs data from multiple gateways. Yeah.
And how easy it is?
How easy it's, okay, so people have done, the Microsoft guys, I can give you some references, have done this thing for wireless access points.
Actually very fast.
Presumably you need to collect the information from the guys in the...
But if it's have a startup policy.
I agree, but at the same time, do you want to spend all your time constantly collecting all this?
No. So that's the answer I don't have. I don't. Obviously, maybe I collect a reading every minute.
Okay.
So if doors change and it's not just
the doors. It's person moving around affects the other kind.
Yeah. Okay.
It's not so dramatic. This is the surprise.
So persons moving will affect RF map. Anytime you do it.
For two reasons, it's surprising. You don't need so much detailed information on the actual RF. In addition, what you need is not changing much.
Is that true?
Yeah.
When you walk around, does it change quite a bit?
But it
Yeah,
doesn't
it
matter
does.
in the communication. It doesn't matter in the communication.
Yeah. So
But he's trying to use this for handoffs. It does matter.
Okay. Read the papers. It's a lot of the detailed information we have in the academic models, right? All of it doesn't matter. A very few things matter.
So, but to answer your
If you
question,
don't know,
Richard,
if you don't know, you get done.
I don't know the answer right now. That's why I said, this is work in progress.
Right.
How sensitive it will prove to be,
Or and how you're going to use it.
right. I don't know the answer, rather than just tell you that I solved the problem, I haven't. So this is the approach we're going. But what are we using this for? We are using this for the capacity. Okay, so the other point I wanted to mention, so as you were moving fast, put 3 base stations in a line, 1, 2, 3. We observed that, again, I'm not saying running, just like one speed is this, the other speed is I was going this, right? So with this speed, I actually handed off from 1 to 3. I never handed off to 2 because these were so small cells. By the time the handoff decision, I was already in the zone of 3. So all I'm claiming is I want to have those type of gross predictions. Where will you hand off? Will you hand off to 2 or will you just go to 3? So it doesn't have to be exactly accurate in the zone of, which is, you said, different people move and, the exact RSSI readings They also change just when I turn around like this, right? But maybe I don't need that accuracy. I just need to know at a systems level, can I predict how many people will hand off to this base station, and can I do some optimization?
The margins for bits to get through, even with the theorems, are much higher than we thought they were 5 years ago. This is the new thing.
And do you also consider the situation where you actually hand these guys back to a macro?
Yes.
application?
Yeah, so that part is, the short answer, yes, that's part of the overall research project. We haven't got that far. So one of the decisions to make, one of the classic decisions that have been made, very obvious, if you're a fast moving guy, you hand off to the macro. Because you don't
Well, you don't
switch,
constantly hand off.
don't constantly hand off. But the reason I said, actually in the previous conversation, we found that the current femtos actually have a capacity of 16 simultaneous active users. So the other reason to hand off, maybe if I predict your movement and I know you're going to a femto which is already saturated, you can't be the 17th guy. So I'll proactively hand you off to the macro. So those are the kind of strategies we are after. But all work in progress.
And these femtocells are connected how?
The femtocells basically plug into the Ethernet, then through the Ethernet they connect to one gateway. So in our campus, we are basically targeting, the exact number is between 200 and 250 femtocells. That's the size of this test bed that we're going after. Okay? And the last piece, as I said, another illustration of a problem I wanted to explain, mobile advertising. Totally different field, okay? So this is coming, you have to have certain beliefs, and we are being questioned on these beliefs. I don't know if they'll turn out to be true or not. So there are two parts of it. So one, ad-supported free apps, very popular. So statistics here, 81% of the app downloads are free. There's some variation across Android and Apple stores. But all of you use some free app. You play, one thing, I don't know how many people play in the US, but in Asia it's crazy, Angry Birds. There's people playing Angry Birds all the time. Free app, right? Now, the other thing that's happening, data plans are going metered, right? You no longer have all you can eat metered plans, especially for 4G and so on, because spectrum is so expensive, people want to move. So what happens as a result of this, we say free is not free, and I'll show you one statistic. So again, it's a lot based on experiments. So we collected, these are the popularity of applications on the App Store. These are the games or applications. These two, let me tell you, this is the rate of app traffic. We had users, we paid them money, they were testing out the ad. We monitored, we routed the phone, we put Wireshark on the access point, so we have exact trace packets. This is the data traffic of the application. So this is what the application needs to send state updates, get, in dictionary, for example, look up the meaning of a word, send it back, etc. This column is the traffic for the ads that get served to the same app. Look at some of the numbers. 0.17 for data, 3.59 kilobits per second for one guy for ads. So in other words, what I'm saying is free is not free. So we did some math and showed, you can do the math, there's some hypotheses and questions, that instead of, if you want to choose between an ad-supported version and a $2.99 version of the same game without ads, if you play the game for 4 months, you're better off buying the full price game, because otherwise the amount you lose theoretically in data transferred by ads is higher.
That's another very interesting application of game theory on games themselves.
Okay, so the whole point here is now people will come back and say, how significant is this? Because, okay, bandwidth is increasing, right? So is ad traffic really that much? So obviously there's no absolute answer, but if you look at a few trends, as I said, we're working with InMovie, one of the biggest mobile companies. So first of all, a lot of these data was collected when you were doing text-based mobile ads. Now they've gone graphics-based. Now you have HTML5-based ads. And the size of those ads, 5 to 10 times larger. After some time, you're going to have video-based ads. You're going to have 3D ads. So the size, it's like an arms race, right? You put more bandwidth, the ad developer gives you richer and fancier ad content.
Did you try to make any effort to collect unused bandwidth at any moment?
No, this is a weak. So we don't know that how much was this affecting the capacity. So we approach this problem purely from the user point and not the network provider viewpoint.
Because people, top companies, they want to understand that, because then if they're going to go to price and scheme, they want to adjust. Exactly. They're going to start. So you get some very, very silly policies around.
Right.
But I would like to know how they correlate with actual.
Yeah, so we will collect, we're nowhere there. So my research idea, very simple. I mean, one basic research idea. There are many other threads, I won't go. So do what mobile file systems, etc. have been doing. Do prefetch the ads when you're at home on a Wi-Fi network or in a femto network. I'll download all possible ads. I mean, now we'll come to the question of what's possible. I'll store them in your local cache, and anytime I need to serve the ad, I'll serve it out of there. I don't want to block the ads, because blocking the ads destroys the whole ecosystem. Right? If you block the ad, the app developer doesn't make money because the advertiser won't pay them. He doesn't pay money, he will no longer release a free app, and you will suffer.
But there's also debate about whether you should pay for those bids, for the bids for the ad or the content.
Exactly. So we'll come. I mean, that's falls very much within the research pattern. So just hold on to your thought, and I'll come back and address that as part of the thing where we are trying to work with startup. Well, let me give it to you now. So the problem is, this again goes back to the philosophy of the telco. The telco, if it realizes that it has to expose more network context to other applications, then, and there's a win-win. So if they, for example, tell the advertising company that right now in this cell, I have a lot of spare bandwidth, so it's cheaper for you to send out the ads. So we can do intelligent prefetching and scheduling of the ads, right? So my phone can get it when it's 0.001 cents to the guy. Because maybe right now nobody is using this cell for whatever reason. So, but that exposure and interaction has to be there between the telco and the applications. And we are trying to foster that through the research group, because they don't directly talk to one another, or they don't have the mindset, let me put it this way.
So monetizing the resource information should be of use, should be valuable. Monetizing the resource information. I give you information about the network, but I want some money back from
That's
you.
not always possible, because that's subjective.
They don't do anything like that. Then the telecom companies.
Yeah, so this is where StarHub, I mean, again, I used one example, I can't speak, I mean, because they're small, they're dense, they've said, oh yeah, really, if we give this information, can we get a chunk of the chain of, for the ads delivered? Then we're interested in doing that. Again, very preliminary, right? I have no reason. So I said it's a 5-year project. Many of these things will play out in 5 years. So the other thing I wanted to tell you, so, the screen got cut off. So location, device, network, user, and others. So you may not be aware that each time you switch from one level to another, Angry Birds, etc., your phone sends all that information about you to the advertisement network. So this comes back to the whole privacy question. So most of us obliviously say, yes, give permission to everything. Okay, let's play the game. We sign the agreement. You have really sometimes no idea how insidious the collection is. It's collecting your gender. It's collecting the speed. Now, of course, if some of these, the device doesn't support, these go empty. In cases where we stand outside, it collects your exact GPS coordinate. So it knows exactly where you are. It can trace. So again, this is the advertising vendor. And typically, also maybe this is not so important, how does an ad actually get serviced? So the mobile application, let's say from AdMob or whoever, gets an SDK. And they make a call to the SDK saying, okay, get me an ad now. So the application has no control on the ad it gets. It trusts the network to give it the ad. So you tell the guy I want an ad, it will basically 3 steps. Go to server X, you go to some server, this is where you pass in all this context. And that guy says, oh, based on this context, you need to get ad number so-and-so, this is the URL, go get it from this server. This is the image or so, and then you get it. So the other thing we discovered is if the ad itself, because it's small screen sizes and so on, was like 4 kilobytes of information, the total signaling traffic for the whole thing was actually about 12 kilobytes. So the overhead of making HTTP calls, passing in the context information, etc., is pretty large because you're doing multiple such calls. So all of it, sort of microscopically goes to what is our alternative architecture, and I'm rushing through a few things here. I'm papering over you can talk to me. So our basic idea is we'll put a proxy on the phone. This proxy is monitoring both your applications and it's monitoring your context. So one of the open questions we have, for which we are collecting real data, this is the real data. So we need to know, the difference between other networks' files prefetching files and prefetching ads is the ads depend on your context. So are you going to play Angry Birds or are you going to play Quake when you go on the train? I need to know that. Which way will you go on the train? You know, what the quality of the network be? Which device will you use and what resolution, etc. How much of it can I actually predict? Because the accuracy of prefetching is based on the accuracy of predicting the context, right? So that's something we need to figure out. But if we have that context, we'll go to the network and we'll do the intelligent advertising prefetcher. This is one of the points where Richie, you were mentioning that this is where additional information from the network might be useful. That it's cheap to prefetch now, it's not cheap to prefetch now, or the cost is different, etc. After we do that, we will locally serve the ad for you when you actually. But there is one other interesting twist, which sets a very interesting computational challenge. So far so good. But there is also, you have to pay attention to the economic model of advertising. It's very important. So in advertising, in the classic sort of click-based advertising, the advertiser doesn't make money until you click on the ad. So why will the advertiser trust a middleware, where the middleware basically can say, like Google paid me money, every time you click, I'll serve you a Google ad. So, because it's disconnected, right? So what it sets up is an open problem of verifying the computation of the local proxy. So you need to be able to show, without actually sending back every ad and every because then the point is lost. We need to be able to show using statistical techniques that this guy is not cheating.
Oh, but I can do this with online hardware easily.
Yes, I haven't.
They did this because they wanted to do the same problem, to find out how many copies of the Chinese were building so that they cannot build more, so that they can take the extra ones and figure out what the design was.
People look at related problems using principal agent models, where you basically have to rely on somebody else to do your job, and there is a monetary transaction.
Right. Like I said, this is again, I won't claim I'm the expert in that area. Okay, so if
But
there's
you
things
can
you want
totally
to
unbreak up the local techniques to do that. And it can be read by one of the states.
Okay.
PPM and they can be to count exactly what's going on. Very accurate, and they cannot break it.
Yeah, but the difficulty. Okay, so I'll give you another.
The difficulty there is that people have to accept to add the extra hardware in the device.
Okay, but there's also sort of in the mechanics of advertising something else. So imagine I'm offline and you are saying I'm playing level 3, I'm a male, so and so, give me an ad. See, the ad is never only one ad. It's 1 out of 10 ads that you can give and the guy makes a decision. Now the other interesting thing is if we look at the ad systems, there is a real-time bidding component from the ad supplier. He may say that I have already served this ad and got 2 clicks, like your Burger King. I already got 2 people clicking on the ad. I'm now not willing to pay as high for the next ad transaction because they basically run a second auction scheme in real time on the other. So in real time, I need to be able to adjust my offline serving logic based on some real-time bidding going on in the back end.
That alone is a very hard problem.
It's a very hard problem. And again, I'm not the guy to solve the problem.
Well, there are many mechanisms, but
There is many companies in the world.
I think that people are working, but designing the correct one is just a very hard problem.
It's not even a correct one.
Yeah, and if you have like pointers to where we should look, or people who should, at the end of the day, a professor is limited by the people whose work. I'm not knowledgeable about this area. So
there's a big problem here about all this monetization, analytics on monetization.
Well, going back to the problem where you have to basically ask somebody to look at the advertisement, that's basically falls under the problem for the Testbed allegation. There's a fair amount of literature.
Okay. So maybe I'll just talk with you afterwards, just get a pointer to that stuff. I haven't thought about it. Okay, so I'm done. I can't, you can read this. I said some applications, I didn't talk about the localizations, I hope what I've done is to tell you that this is what the testbed is. These are the types of problems on the testbed. So if any of you are interested, the last thing I want to say, there are a few things going on. We are actively searching for faculty, postdocs, as well as PhD students. I'm not here to steal your PhD students, but if they want to come and spend 6 months to work on something that is of mutual relevance. We have the money and etc. to support that. And that was the purpose of this conversation. As I said, it was an evangelization, not so much a talk on a particular research topic. Okay, thanks very much.
Thank you very much for a very interesting talk on some of the current problems. Any more questions? Have you been all evangelized?
Yeah.
Huh?
Yes.
Politically incorrect.
Technical evangelism is okay.
Windows service.
Yes.